Hello and welcome to Math Excel Educator. In this video, I'm going to discuss linear inequalities, particularly the shading of regions. Some students they find this topic hard as they do not understand which side of the straight line would their inequality fit and also which side to shade or unshade when an inequality or a set of inequalities are given. Let's get started. And before I take this question, let's quickly check out the rules about boundaries and shading of regions. When an inequality includes equal to, that is less than equal to or greater than equal to, the boundary line must be included in the graph and it is shown as a solid line. When an inequality does not include equal to, that is less than or greater than, the boundary line is not included in the graph, so it is shown as a broken line. See, in this question, you have a graph and there are two portions or regions which are shaded. First of all, the equation of this broken line is y is equal to 4, and the equation of this solid line is y is equal to negative 2. See this line, which is a solid line, and so the inequality will take a less than or equal to or greater than or equal to. For this shaded region below this line, y is equal to negative 2, this will be y less than or equal to negative 2, and the region above, which is unshaded, will be y greater than or equal to negative 2. Now for the region in green, the line is a broken line, and so the inequality will take a less than sign or a greater than sign. For the region above this line, it will be y greater than 4, and the unshaded region below is y less than 4. Here we have two vertical lines. The equation of this dotted or the broken line is x is equal to 1.5 and the equation of this solid line is x is equal to negative 2.5. This is a solid line, so the equation for this region, the inequality, would be x less than or equal to negative 2.5, and the other side of the line would be x greater than or equal to negative 2.5. For the region in green, the line is a broken line, so the shaded region would be x greater than 1.5, and the other side unshaded is x less than 1.5. In this example, we have two lines which are tilted. The equation of the solid line is y is equal to 0.5x minus 1, and that of the broken line is y is equal to 0.5x plus 1. Now, if I assume that the inequality for this shaded region with the blue is 0 y greater than 0.5x plus 1, then let us test it out on a point from this region. Let me take the point as, say, negative 4, negative 0.5. We put the value of x and y into this inequality. So this will be negative 0.5 greater than 0.5 times negative 4 plus 1. So you get negative 0.5 greater than negative 1. This statement is true statement, and so the region or the region in blue is correct, which is y greater than 0.5x plus 1. So the other side of this line, the inequality would be y less than 0.5x plus 1. Now for the other part, that is the green region, if we take the shaded region as y less than equal to 0.5x minus 1, and let's test it on a point. Let's say the point is 4, 0.1. We put the values of x and y into this, and so we get 0.5 less than or equal to 0.5 times 4 minus 1, which is 0.5 less than or equal to 1. Here, this statement is a correct statement, and so the inequality for this region is correct. Remember once again that if the line is a solid line, then we have to use either the greater than sign, greater than equal to sign, or less than equal to sign. So in this case, the other part, unshaded part, would be y greater than or equal to 0.5x minus 1. Here, in this example, I have a very simple inequality. Minus 2.5 less than x is less than 5.5. There are two broken lines. The equation of this line is x is equal to 5.5, and the equation of this line is x is equal to negative 2.5. The equation of this region would be x greater than 5.5, and so the other side would be x less than 5.5. Similarly, this region for the line x is equal to negative 2.5, this is x greater than negative 2.5, and the other part would be x less than negative 2.5. Now if you take the middle part, which is the shaded region, we can finally say this negative 2.5 is less than x is less than 5.5. Here, in this question, the graph has two solid lines, horizontal lines, whose equations are, this equation of the line is y is equal to 1.6, and the other line is y is equal to negative 2.5. For the bottom line, the unshaded region would be y less than or equal to negative 2.5, and the shaded region above this would be y greater than or equal to negative 2.5. For the line above, the bottom of this line, the shaded area, is y less than equal to 1.6, and the region above is y greater than or equal to 1.6. So the part in the middle which is shaded is negative 2.5 less than or equal to y less than or equal to 1.6. This question is a bit different from the previous questions we did just now. Here, in the graph, you see a shaded region in blue and also an unshaded region. In this question, first of all, we need to find the equation of the broken line. We remember the equation of any straight line can be y is equal to mx plus c. Let's quickly fetch what is the gradient or m of this line. The gradient or slope m of this line will be negative 1, and c, which is the y-intercept, is 3. So the equation of this line is negative x plus 3. So the equation of this line is y is equal to negative x plus 3. Now, the region in blue will be y greater than negative x plus 3, and the unshaded part will be y less than negative x plus 3. In this question, we have a line which is a solid line. Once again, let us find the gradient of this line, which is negative 3 over 2, and the c, which is the y-intercept, is 0. So the equation of the line is y is equal to negative 3 over 2x. So the equation of the line is y is equal to negative 3 over 2x. The shaded region is y greater than or equal to negative 3 over 2x, and the unshaded region is y less than or equal to negative 3 over 2x. In this question also, let us find the gradient or the slope m. Here the slope is 1 over 3 and the c, that is the y-intercept, is positive 1. So the equation of the line is y is equal to 1 over 3 x plus 1. So the equation of the line is y is equal to 1 over 3x plus 1. The shaded region will be y greater than or equal to 1 over 3x plus 1, and the unshaded region is y less than or equal to 1 over 3x plus 1. Here, once again, we need to find the equation of this broken line. For that, the gradient of this line is 2 over 3, and the c, which is the y-intercept, is negative 1. So the equation of the line is y is equal to 2 over 3x minus 1. The equation of this line is y is equal to 2 over 3x minus 1. The shaded region can be represented as y less than 2 over 3x minus 1, and the unshaded would be y greater than 2 over 3x minus 1. Here we have a set of inequalities, and we need to show by shading the unwanted regions. By shading the unwanted regions, show the region defined by the set of inequalities, that is x plus 2y greater than or equal to 6, y less than or equal to x, and x less than 4. So this line is x equal to 4. This line is y is equal to x, and this line is x plus 2y is equal to 6. Now observe, for the blue shaded region, this is x greater than 4, other side is x less than 4. For the line y is equal to x, this part is y less than equal to x, and the shaded is y greater than or equal to x. And for the other one, which is x plus 2y equal to 6, this is x plus 2y greater than or equal to 6, and the bottom part would be x plus 2y less than or equal to 6. So if you take all the three inequalities together, then the part which is unshaded describes these three inequalities, which is shown in the intersection of the three lines. I hope you enjoyed the lesson. Thanks for watching.